with another update to the Brighter Broker real estate app for Salesforce and other systems as well. There will be other features that integrate with other applications like Facebook, Twitter. I'm not sure which database, but most likely Snowflake, a data warehouse, which I hope to use to store a lot of the property data. But let's get into it. So this feature involves matching strings. So real estate data, and this is a huge problem in real estate. Data comes in messy. You know, you're dealing with people across the country who are recording these property deeds and all this data, realtors, whoever involved, who are behind these APIs, and the data is always messy. So dealing with that is a significant issue. So right now, and the first one I want to tackle is our subdivisions. Now I did create a subdivision custom object, and this is so that users can track data at the subdivision level, which will bubble up to the farm. So an agent will have a farm that they work. Maybe it'll be 3 or 4 subdivisions, that kind of thing. But subdivision data is good to have. Knowing how many homes are there, the average turnover, that kind of thing. And all these things I'm going to be adding later on. But right now, we want to tackle the problem of let's go back to the property we had. Okay, so here's an example, 2304 Julie Court, fairly new home built in 2015. And the API for the sale and mortgage API, so the API used for the sale and mortgage information provides sometimes really good subdivision information, sometimes it's terrible. So this one seems okay. So basically what we're going to do, we have to match 2 strings. And if you've ever tried to match strings using Excel or whatever, using a fuzzy logic or a regex, which is more popular for developers, it's something that sometimes it can work, sometimes it doesn't. So I just showed you the subdivision object. So that's the one that's going to be, that's the source of truth. The subdivision object is likely the proper name, or as close as possible to the proper name for the subdivision. And then we have the subdivision name the way it comes in the API, which is called vendor subdivision. And here I have a little tooltip just reminding the user that it's the inconsistent version. But that's what I'm using in the Apex behind the scenes. So in the beginning, I thought, okay, I can write an algorithm that will identify, matches. So it'll take 2 strings and create a match. And I decided to use ChatGPT to do that. I said, well, let's go ahead and ask ChatGPT which algorithm would help me accomplish that in Apex. And it returned a value that I'd already known about, was called the Levenstein algorithm. And the Levenstein algorithm basically calculates the cost to make 2 strings equal based on deletions, insertions, and removals. So removing data from one string to make it the same as another string. How many operations does it take to do that? And that's the result is a value, which we are calling threshold. And so follow me here, because I know it's getting a little in the weeds. But basically, and let's go ahead and find this class. So all I'm going to do is provide a threshold, which I've set at 5. And this is based on iterations. I did have to go back and forth a little bit and see what the proper threshold would be. And basically, once we plug this threshold, once we calculate this Levenstein distance, if it's less than or equal to the threshold, then we're considering these strings equal. And this seems to be the best for this data set. I think that depending on the data set, the threshold could be different, but for right now, I'm using 5. I think later on, I'm probably going to do some analysis where I calculate the thresholds and then use, the minimum value, and that way, the threshold will be an equal set of strings will always be accurate based on that data set. So if you calculate enough of these, if you have a large enough data set and you calculate enough of these, then you can get pretty close overall. But right now, I just use an arbitrary threshold of 5. And with that, I created another class. So this class is just calculating, I call this fuzzy matching, is checking the match using the get Levenstein distance. And ChatGPT tried to give me an entire algorithm to write, and I think I have that to show you. So it wanted me to write an entire algorithm, which and it's not even correct. I mean, I took the paragraphs that ChatGPT returned, and but this was not even correct, and didn't write it in Apex either. The value, I don't even know what language. It's mostly because Apex is based on Java. It's very similar to Java, but it tried to use two-dimensional arrays to calculate the Levenstein distance, and two-dimensional arrays aren't supported in Apex. I mean, there are different ways you can do that, but not the same way as in Java. So it was totally wrong. And good thing Salesforce does have a get Levenstein method built in, so which makes my life a lot easier. So I just use Salesforce's built-in get Levenstein distance method. I set my threshold at 5, and I ran the calculation. So let's go to, one other thing I did, I created a trigger, and we also had a trigger that runs. Let's go ahead and delete these because we don't need the after insert version. But I also created a trigger. This one does get property data, so this one calls the API that gets property information on update, or after insert. I'm sorry. And then the other version, to refresh the data, we use a button, a Lightning Web Component button. But then, before update and before insert, we are calling this get Levenstein method, and we are updating the subject property. And I have some debug logs in here just so I could check the property information, which are no longer needed either. So let's go ahead and get rid of those. But we are just updating the subdivision based on the result of that matching algorithm. So let's swing back over there real quick. And here is the matching algorithm. Well, here is the method used to run the matching algorithm, because Salesforce has it built in. All I need to do is determine when to run it, because as you know, Salesforce, it's very computationally expensive, so we have to be careful about how we choose filters and that kind of thing. So I do have to do a null check to make sure that one of the string values, the subject vendor subdivision field, is not null, because I did run it without including that and got a null pointer exception. And then we're matching the subject property zip code with the zip code from the subdivision object. And that way you're filtering on zip code. So you're not exploring all of the subdivision object records in Salesforce. You're only exploring the ones in that zip code. So it will never really query too much. I don't care what zip code it is. You're not going to have too many subdivisions to query. So then the result is a Boolean string, because remember that algorithm is a Boolean result because it compares the Levenstein distance with the threshold value that we set. If it's less than or equal to that threshold, then it is a match for our purposes. and then it returns an ID value, and we use that ID to update in the trigger. We use that ID to update the subdivision lookup value. So let's go ahead to the actual Salesforce record and check it out. So here we are. We have this property, 2304 Julie Court in Haverty Grace, Maryland. As you can see where it's located, right off of Route 40. Pretty nice neighborhood. And we know this is going to run on after insert and after update. So we have the value here. So the vendor subdivision value comes from the sale and mortgage record. So we already have that. And so we're just going to edit it and then update. And it looks like it did not find a match here, which is weird because Fields of Rock Glen, let's go take a look. Should be Fields at Rock Glen. So maybe the Levenstein distance is a little too much, it's too high. So let's go take a look at what the actual Levenstein distance is for that calculation. So okay, so it's 16. So it did not find a result there. Like I said, it's not perfect, but what we don't want are false positives. We're okay with false negatives, but we don't want false positives because we don't want the wrong subdivision being associated with that property, because that could get messy for the user. So we're going to go ahead and we'll try another one. This one, actually, we can do this one all the way through because it doesn't have any information. All this one has is the data that we imported from a tax record. So really, this is wrong. Hartford, Maryland, it's all combined. So what we're going to do here, we're first going to refresh property data, and we'll give it a few seconds to call the API, and then we'll click refresh. Okay, we have a picture, we have a zip code, we have information. Last sale date was in April of 2021. And so let's go ahead and create a sale and mortgage record. So as you know, I did mention before that this will update the sale and mortgage name, so we really don't need to put anything in here, but just to satisfy this requirement, we'll go ahead and put an A there, but you can put anything. Right now, this is calling the API in the background, and it looks like it's returned a value. So, and look, so Eagles Rest 05 is the value that came back from sale mortgage record retrieval, and Eagles Rest 05 is the inconsistent subdivision value that comes through the API in the JSON. So the trigger found Eagles Rest subdivision and matched it. So that one did work, and we quit while we're ahead, right? But no, it's a work in progress, but we do see that the algorithm does work. It's based on a threshold that we have to set, and I think through analyzing, a lot of data, we can probably set a threshold based on how large the words are, that kind of thing. ChatGPT did tell me that I should not set the threshold value based on using a percentage, or based on using how long the words were. I'm thinking I should. The threshold value should be based on how long the strings are, but there are probably other ways to figure it out. But that's something I'm working on as well. But I think that really nailing down the use of these fuzzy matching criteria, the Levenstein method, other regex systems, using some NLP to start parsing out data like condos, which condos are really difficult. I was able to retrieve this information for this condo from the API, but it's not always perfect because you have that condo unit number. And I've worked with APIs in the past where condo units, apartment numbers, those kinds of things weren't properly handled by the API, by the system. So it's another challenge. I'm looking forward to working on some of this fuzzy logic and some of this regex and the NLP methods to really start manipulating some of this real estate data. So that's all I have for today. Hopefully I'll have some more for you over the next couple of days because I'm off. I want you guys to have some happy holidays, Merry Christmas, and feel free to comment wherever you see this. I'm also going to be loading all of these videos up to YouTube as a series. So feel free to reach out, and look forward to hearing from everybody. And again, happy holidays and happy New Year. Have a good one. Thanks. Bye. I was mentioning in that text in the video in the middle where I thought this one would not match. We're going to try it again because I realized that we don't have the zip code here. So, which I added today, just today, I added the zip code as part of the API results, which comes back in the JSON. I wasn't getting it before, I didn't think I needed it, but it's probably good to have all of the address fields separate for a variety of other queries, which I'll have to add later. But for right now, all I did was add the zip code today. So let's go ahead and retrieve it, and then we'll see if we can update the record again and see if it works this time. So there's the zip code, okay, 21078, returned from the API. And from here on, this will come in with the original property record, so that won't be an issue. And here we go. So we got a perfect match. The subdivision fields at Rock Glen match the data, the field data, the way it came in from the API, and it works exactly like we want. So thank you very much, and you guys have a good one. Goodbye.